In this video, we're going to spend a few minutes talking about three properties of logarithms that you're going to use to simplify and expand some expressions. So the first property of logarithms says if you have some log, and it doesn't matter what base you're working in, of x times y, and you can rewrite that as the log base c, in this case, of x, plus log base c of y. And an easy way to remember that is, if you remember, logarithms are just a different way to write exponents. Then when you multiply with exponents, or when you have a multiplication problem that involves like bases, you add your exponents. So multiplication problems become addition problems. Using that same idea, then we could look at the next property that says that the log of x divided by y is equal to log base c of x minus log base c of y. And again, go back and remember that when you're working with exponents with like bases, when you have a division problem, you subtract the exponents. Then the last property says that if you have log base c of x to the y, so you've got an exponent, remember that when you're working with exponents, if you raise an exponent to another exponent, you multiply. So what happens is our exponent comes down to the front and multiplies with our logarithm. So that becomes y times log base c of x. Now we're going to just take the rest of this video to look at how to apply those to expand our different logarithm statements or to condense them. So our first problem says we have log base 2 of 4 times x times z. So what's going to happen is, because this is all multiplication, this could break down into log base 2 of 4 plus log base 2 of x plus log base 2 of z. When we have multiplication, it becomes addition problems. Now, one of the things you do need to check with numbers is, can I evaluate these? So log base 2 of 4, remember, means 2 to the what equals 4. And I actually know a value that would be 2. So this could be rewritten as 2 plus log base 2 of x plus log base 2 of z. In our next problem, we have a division problem. So we could rewrite this as the natural log of b minus the natural log of 5. Because our property says when we have division, we can rewrite it as subtraction. Now, I'm not responsible for knowing the natural log of 5 without a calculator, because remember, that means e to the what equals 5. And we're not supposed to know that one off the top of our head, so we would just leave it like that. Then the last problem we have on this page is log base x to the 7th, or the log of x to the 7th, which we have an exponent, so what we're going to do is take our exponent down to the front and make this 7 times the log of x. And that's just how simple those are to use. Now let's look at a couple examples of where we might have more than one property being used at one time. So let's look at this first one. Notice that we still have all multiplication. So this is going to simplify or expand out to log base 3 of 5 plus log base 3 of x squared plus log base 3 of y. And notice that the log base 3 just goes with every one of those different terms. Now I want to look to see if I can do anything with these after I've got it expanded. Well, log base 3 of 5 would mean 3 to the what gives me 5. I don't know a number for that, so we'll leave that one. It's log base 3 of 5. But I can use my other property of logarithms that says when I have exponents, they get to come to the front. So this becomes plus 2 log base 3 of x plus log base 3 of y. Last one where we're going to actually expand. We have a natural log, and this actually has all three properties involved in it. So notice that I have a multiplication in the top, and then I have division. So this would rewrite as the natural log of a cubed plus the natural log of b, that takes care of the multiplication on the top, minus the natural log of the square root of t, because we have division, So we subtract the denominator. So now I can take my exponent here, bring it to the front, and make this 3 natural log of A plus the natural log of B minus, and you might think you're finished here, but you've got to remember, we've talked about this previously, the square root of t is the same thing as t to the 1/2. So then I have an exponent that would come down to the front and give me minus 1/2 the natural log of t. Now we're going to take a few minutes and go backwards, and we're going to condense these into one logarithm. So we have multiple logarithms we're going to condense down to one. So look at our first problem. Notice that we have an addition between them. Now working backwards, that means that we need to put these together as a multiplication problem. So this becomes log base 3 of b times t, or just log base 3 of bt. In the second example, we have a subtraction problem. Remember that those go together as division. So it'll be log of z over a. And in our last little example here, we have 3 natural log of p. Now we're going to work backwards, and we've got a number in front of our logarithm. So remember, that used to be an exponent. So this could be written as the natural log of p cubed. So now we're going to look at a few examples that are a little more complicated because we have more than one property being used. So let's look at this one. We have 2 log of r plus 5 log of s. So the first thing you're going to want to do is take your exponents back up. Now remember, that's usually the last thing that we did when we were expanding. When you condense, you work backwards. So this becomes the log of r squared plus the log of s to the 5th. But then we have this addition sign, which tells me that I can put them together as multiplication. So it becomes the log of r squared times s to the 5th. Notice that there is only one logarithm in the final answer. All right, let's look at another one. We have 1/3 natural log of t minus 5 natural log of s. So again, let's move our exponents back up and get the natural log of t to the 1/3 minus the natural log of s to the 5th. But then that becomes, because it's a subtraction problem, a division problem, the natural log of t to the 1/3 over s to the 5th, which could then be written as the natural log of the cube root of t, something to the 1/3 is a cube root, over s to the 5th. All right, let's look at one last condensing problem. This has all of the different properties of logarithms that we've talked about in it. So we're going to start by moving our exponents back up. So this is going to become log base 2 of j cubed plus log base 2 of m to the 5th minus log base 2 b to the 4th. Now I've got an addition here, which means I can put those together as multiplication. So I'd have log base 2 of j cubed times n to the 5th minus log base 2 of b to the 4th. But then those can go together because we do have subtraction. Those can go together as division. So my final answer would be log base 2 j cubed m to the 5th over b to the 4th. All right, last thing we want to do in this video is we're going to look at something called change of base formula. Change of base formula is used when you need to evaluate something like maybe log base 7 of 15, where you're wanting to know 7 to the what gives you 15. Now, as I've been telling you, on your calculator, the log button is log base 10, but I need to do a log base 7 problem. Well, that's what change of base formula allows you to do. It says, okay, let's say you have log base b of a. So like log base 7 of 15. If you can't evaluate that logarithm, you could rewrite that in terms of a different base and then evaluate it using log base c of a over log base c of b. Now that may look confusing, but here's what we're saying. If I go back to the problem here, where I had log base 7 of 15, I don't want to work with log base 7 because my calculator won't do that. So what I can do is rewrite that in terms of log base 10, or just the common logarithm. And I would do log of a, which would be 15, over log of 7. And then I can use my calculator to figure that problem out, or that answer out. Now, one way I remember this is I use this little mnemonic device that says that you can do log of the tall over log of the small. Now, you just have to remember that I'm not talking about the value of the number. I'm actually talking about size of the number. So the tall number would be here, the A, and then the little subscripted number is the small. So it's log of the tall over log of the small. So it's, in this case, log of 15 over log of 7. You also can do these with natural logs because that's just log base e. So I could do the natural log of 15 over the natural log of 7. So if I look at this problem, now that I have for an example, if I want to do log base 3 of 5, then what I can do is just take log of 5 over the log of 3. And then I can grab my calculator. You might want to do this and do the log of 5 divided by the log of 3. And I get 1.465 if I round. You also get the same answer if you do the natural log of 5 over the natural log of 3. Let's do one more, log base 7 of 4. I'm going to do the log of 4. Notice that's not the biggest value, so when I say tall over small, there's the tall, there's the small. So it'll be log of 4 over log of 7. So if I use my calculator, I get that gives me 0.712.